Hi and welcome back to my channel. What is the radius of this circle? This week is going to be a pretty quick problem, but can you solve it? We have got a chord going across the circle here, split by this line BD into line segments 20 and 36. Can you find the radius of the circle? If you want to solve this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I wanted to do with this is to extend the line BD like this, okay? Now from there, I can work out the length from D to the circumference of the circle on the other side, this length here. Okay, now I can use the intersecting chords theorem to do that. And the intersecting chords theorem says if you go from the circumference to the point of intersection on one chord times by the other end of that chord on the circumference to the point of intersection, that will be equal to the same thing but using another chord. Okay, so what that means is that 20 times 36 would be equal to 15 times x, where x is this other length of the chord that we're going to try and work out. We want to work out. Okay, so 20, this length here, times by 36 is equal to 15 circumference to the point times by circumference to the point, which we've called x. So that gives us 720 is equal to 15 times x. Divide by 15 on both sides, we get 48 is equal to x. Now let's put that on the diagram like so. Now the next thing I want to do is I'm going to draw a radius, and I'm going to draw that vertically up, but importantly I'm going to draw it perpendicular to the chord, the red chord. Okay, now the reason I've done that is because I know when a radius is perpendicular to a chord, it is going to bisect that chord. Now at the minute that chord is going to have a total length of 20 and 36, which is 56, and if we divide that by 2 we get 28. So we then get these lengths here, okay, 28 and 28. Okay, it's not a bingo shout out, but it does sound like it. Right, now from there what I'm going to do is I'm going to draw another radius across here. Okay, so I'll just do that again. I'm going to introduce another radius to the left like so. Now that will also be perpendicular, and what that then means is that it's going from 48 add 15, which is going to be 63. I'm then going to half that to 31.5 because again it's perpendicular, so it's going to bisect the chord. So the length from here to here is going to be 31.5, and it will be the same on the other side. I just haven't put all the lengths in, specifically the length from the red chord to the point D here. Okay, I haven't labelled that point because I don't need it. Now I've also put on this length here, D, sorry not D, 8, because if we look above at the point D, across, that is a length of 8, and obviously that is parallel, it's going to be the same length. Okay. Now from there I'm going to draw another radius on, and I've got a right angle here. Now because I've got that right angled triangle, I can use Pythagoras, which means that 8 squared add 31.5 squared and square rooted will give me the length of the radius, which is 32.5. I hope if you tried this problem yourself you were able to get that. Now I know there's a few different ways to do this problem, so if you had a different solution, if you use a different solution, please put it down in the comments below. All that is left to say is thank you so much for watching. If you enjoyed this video, please consider liking, and if you're not already, consider subscribing to the channel. Thank you so much for watching. There is going to be another video just up here for you that you can click on to help promote the video in the algorithm, but also it should be something you want to watch. Like I say, thank you for watching. See you next Monday at 5 PM for another problem solving video. Until then, bye bye.